Hello everyone, we are from Group 2, which consists of DARSHANAA, DIVIYA, EILEEN, and JASMINE. We are going to talk about the Experiment 5, Measurements of Jet Forces. The first one is the report summary. The lab experiment 5 is the study of measurements of jet forces. A jet of fluid will generate forces when it hits a surface such as a flat plate or hemispherical surface due to change of momentum of fluid, according to Newton's second law of motion. The force exerted by a jet of fluid on the surface can be calculated by using the momentum equations. The measured force and percentage of relative error will be calculated in this experiment. This experiment is aimed to compare the force exerted by a fluid jet impinging upon a flat plate or a hemispherical surface with the theoretical values. The apparatus that we use are wet positions, deflector, nozzle, main switchboards, flow control valve, volumetric measuring stand, sliding tank, water drain, water supply tank, and lever mechanism. The summary, we can conclude that the value of forces from the equation is slightly different with the theoretical value due to the error or inaccuracy of the measurement scale. We also can conclude that the force exerted on the hemispherical plate is greater than flat plate due to the structure of the plate. The flat plate has a high percentage error compared to hemispherical plate. The force exerted from the jet is directly proportional to the water velocity. Hence, the greater the surface area, the larger the momentum and velocity, which will causing the increasing in the water velocity, and thus the larger the force exerted by the jet on that surface. The factor contributing to errors or incoherency in experimental data is parallel error, which will occur when the eyes are not perpendicular to the measurement scales. We need to measure that our eyes level is perpendicular to the measurement scales during taking data to avoid the parallel error.
Okay, so I will be talking about the theory for experiment 5. A jet of fluid, when impinging upon a flat plate or a hemispherical surface, generates a force due to change of momentum of the fluid according to Newton's second law of motion. For example, when a velocity of water from jet nozzle with diameter strikes on a flat plate or a hemispherical surface, the rate of change of momentum produced and its magnitude is the same with the force exerted on the surface of the flat plate / hemispherical surface to support the water jet. The ebb generated by a jet of water when it strikes depends on the shape of the surface. Figure 1 and Figure 2 depict a jet of fluid issued from a nozzle of diameter, moving vertically upward with velocity and striking a flat plate and hemispherical surface, respectively. The jet is deflected by the surface of flat plate / hemispherical surface through an angle theta and leaves the surface with velocity. Next, Figure 1 depicts the jet of fluid when striking a flat plate. Figure 2 depicts a jet of fluid hitting a hemispherical surface. Next, the theoretical force generated when jet of fluid strikes a flat plate and a hemispherical surface can be seen by the formulas below, where F is the theoretical force exerted on the flat plate / hemispherical surface, A is the cross-sectional area of nozzle, rho is the density of water, theta is the angle of water flow after impact on the surface, V1 is the velocity of water jet before impact on the surface, and V2 is the velocity of water after impact on the surface.
So this is the methodology to for the experiment. First one, we have to determine the two different types of deflector, which is flat plate and hemispherical surface. Second, we must remove the cover together with the lever mechanism and assemble the tested deflector, which is the flat plate. The fourth step is to place the cover with assembled plate at the lever mechanism back into the tank. Next, we are to tighten the three screws to the cover and set the pointer to 0 by adjusting the screw at lever mechanism. Then, turn on the main switch and the pump and slowly open the flow control valve until maximum flow. The ninth step is to put the desired weight on the lever mechanism and stop until the pointer at lever mechanism is at 0 notch. Next, we are to close the sliding valve and determine the flow rate of water by recording the time taken to fill up 3 liters volume of water in volumetric measuring tank. So for the second reading, we need to reduce the desired load weight and adjust the flow control valve and stop until the pointer at the lever mechanism is at 0 notch. Again, record the time required to fill up 3 liters volume of water in volumetric measuring tank to determine the flow rate of water. For the 17th step, we are to repeat the procedure by decreasing the desired weight until the flow control valve is at minimum opening. Lastly, we need to change the deflector from flat plate to hemispherical surface and repeat the procedure by using appropriate load weight.
The next one is the raw data analysis. This is the data for the flat plate, which we need to calculate the flow rate, velocity, the theoretical force, and to calculate the percentage of relative error by using the formula measure the force minus theoretical forces divided with the theoretical forces times 100%. Next. Next one is the data for the hemispherical surface.
Okay, this is the table 1 data for the flat plate, where the force measured are in decreasing value, while the volume of the water collected is constant, which is 2 liter, while the other 5 parameters are consistently fluctuating. Next. So this is table 2, data for hemispherical surface. This one as well, the measured force is decreasing as well, and the water volume of water collected is constant, which is 2 liter, and the other 5 parameters are also consistently fluctuating. Next. Next. As for the discussion, the first one is the plot a graph of log measured force versus log volume for both the flat plate and hemispherical surface on the same graph. So this is the data obtained after logging the volume, measured force, and theoretical force for both hemispherical surface and flat plate. Next. So this first graph, which is log measured force versus log volume for both hemispherical surface and flat plate in comparison, where in which we can see that the measured force for hemispherical surface is greater than the flat plate. Next. So this one is the second graph, where for which is log theoretical force versus log volume. This one as well shows that the hemispherical surface has greater force than the flat plate. Next. So the first one is estimate the slope of the graph for both the flat plate and hemispherical surface and compare with the theoretical value as shown in equation 2 and equation 4 respectively. Comment on the difference. So for the hemispherical plate, the linear equation of theoretical force according to the plotted graph is y equals to 2x minus 0.804. From the graph of log measure force versus log volume, the equation is y equals to 1.84x minus 0.686. As for the flat plate, the equation for theoretical force is y equals to 2x minus 1.11. The equation of measure force is y equals to 1.7x minus 0.905. So there is a difference between the volume of slope in graph and the theoretical force of hemispherical surface plate and the flat plate. This is because there is difference in the force impact toward the flat plate surface due to the different angle of the water impaction, causing the volume of the value of the slope in the graph is different than theoretical value. Next. Roman 1b is about estimate the y-intercept ratio of hemispherical surface to flat plate and compare with the theoretical ratio as deduced from equation 2 and equation 4. Comment on the difference. So for the theoretical ratio of y-intercept of hemispherical surface to flat plate is calculated as follows, which is the log 2 times density times area is for the hemispherical surface, while log density times area is for the flat plate. So from calculating using the formula as follows, we get the theoretical ratio of y-intercept of hemispherical surface to flat plate is 0.7276. Next. As for the y-intercept ratio that for the measure force is we can get from the graph from of the log measure force versus log volume, where the y-intercept for hemispherical plate is negative 0.686, while for flat plate is negative 0.905. So the ratio that obtained is 0.758. In real situation, there will be minor and major losses of the fluid when going through the pipe and striking the plate. So there is a difference between theory value and measured value. Next. C is about compare the force exerted on the hemispherical surface with the one on the flat plate, which one is greater and why. So from the experiment, we can say that the force exerted on hemispherical surface plate is higher due to the momentum produced, which is higher than flat plate. The force exerted on hemispherical plate is greater than the flat plate because it lies on the behavior of water jet when it strikes the flat surface. It forms a radial sheet which impinge on the inner wall of the surrounding cylinder, and it divides some of the water flowing down the cylinder wall and the rest flowing upwards. Although visibility is impaired by the spray which is generated, it does seem that some water falls on the top side of the vane. This would have the effect of producing a small momentum force in the downward direction, so reducing the net upward force of the vane. So as for the flat plate, the theta is 90 degree, and the formula is for theoretical force is density times area times velocity to the power of 2, while for the hemispherical surface is the theta is 180 degree, and the formula of theoretical force is 2 times density times area times velocity to the power of 2. So from the equation itself shows that the force acted on the hemispherical surface is 2 times greater than the flat surface. Next. Secondly, compare the percentage of relative error for both the flat plate and hemispherical surface as function of jet velocity. Comment on the analysis and explain your reason. So the comparison between the percentage of relative error for both plates based on our data, the percentage of relative error from the both plates are different. That is, the average for the average relative error for the flat plate is 14.319%, and for the hemispherical surface is 10.923%. So from the experiment, we can see that the percentage of relative error for both the flat plate and hemispherical surface shows a fluctuation, which is from high goes to low and goes back to high. The shape of the plate can be the source of error. This is because the equation using angle, which is the impact of velocity from water to the surface of the plate is might not in perfect shape, or in case got incomplete sphere, the angle will be different, which result in obtaining a different force. Other possible source of error could be the spring coil. The shape of coil must be in standard position, which is straight. If not, the velocity which is applied by the water is inaccurate. Next. Briefly discuss factors contributing to error or inaccuracy in experimental data and the possible recommendations to improve the existing results. So first one is the error in calculating due to the uncertainty in measurement as well as mistakes made during calculating the results. Second is the pump velocity was not precise and the existence of air bubble in the pump might occur. Third is control valve may not open fully. Fourth is parallax error may also occur, like observer's eyes are not perpendicular to the scale of measurement and readings. Lastly, the spring used also may lose its elasticity, and this can cause systematic error and all the reading will be wrong. As for the recommendations, repeat the experiment at least 3 times for each reading to get the true value by finding its average. Second is opening the valve to remove the air bubbles that may present in the pump before the experiment starts. Third is making sure the control valve is fully open when conducting the experiment. Fourth is the parallax error can be prevented by ensuring the observer's eyes are on the meniscus of scale when collecting the data. Fifth is the check check the spring before conducting the experiment and replace the spring if necessary. Lastly, use plates that have a perfect shape to increase the accuracy of force exerted on the plate and thus giving a more reliable data. Suggest to of jet impact in industry. So the first one is jet is used to rotate the turbine, namely Pelton wheel in the generator. The water jet applies force tangentially to the wheel. The tangential force of the water jet generates moment or torque on the wheel to its maximum value. Therefore, it increases the mechanical energy of Pelton wheel, and the rotational energy of wheel then is converted to electrical energy. Second application is jet impact is also used as water jet cutter. Water jet cutter is capable to slice metal or other material by using high pressure and velocity of water jet together with abrasive substance. The process of water jet cutting is similar with the water erosion found naturally, but occurs with highly accelerated and concentrated water. I will pass to the next presenter.
Okay, wait, guys. I will cut this part. Oh, am I presenting?
You are presenting my slide now, not in the conclusion.
Yes.
Hmm.
Oh, okay, 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 okay. Oh, wait, wait. Okay, okay, okay.
The conclusion is we have that, but then the like main topic slide is not there.
Oh, okay, all right.
Uh,
Can you guys hear me?
yeah, that's why I respond you.
Okay. Okay, I'll start from here. So this is the conclusion. Uh, the objectives of this experiment has been accomplished by comparing the force exerted by a fluid jet impinging upon a flat plate or a hemispherical surface with the theoretical values. Second one, a force is applied on the plate due to the change of momentum when the fluid jet both impacted on a flat plate and on a hemispherical plate. Next, the force acting on the the force acting on the plate will be equal to the rate of momentum. And next, the force acting on the hemispherical plate will be double of that acting on the flat plate. Lastly, the greater the angle of deflection of the water jet, the greater the change of momentum. So these are the references. That's all from our group. Thank you. Yeah, where's my meeting? Okay.
Should we wait, like, for you to check the video, see whether okay or not?
You can, because if wait,
Okay, okay.